Hello.
Hi, can you hear me?
Yes, I can hear you. Sorry for the delay.
Okay, that's fine.
All right. So um, I'll actually just lay out the format of the interview. And if you have anything that you would like to actually practice on, you can let me know, and I'll try to actually ask question accordingly.
Okay. So I'm looking for algorithms and data structure mock, any kind. I'm targeting L4 positions.
Okay.
Yeah, and
Um,
I'll be coding in Python.
all right. That's all right. Okay. So, all right. I have a question for you.
hmm
So before we actually go into questions, do you want to do any behavioral type questions, or we can just dive right into the question?
Um, let's dive into the questions.
Okay, sounds good. So you can
Thank
see the
you.
screen, right?
Yeah, I can see the screen.
Okay, so the question is that you're given, and you'll have a lot of flexibility in this question. So, if you have um, any questions that you want to ask, you can ask them, and we can actually solve this problem together. I just want to see how you solve it.
hmm
So the question is that you're given a set of data. Let's suppose um, name. Let's suppose this XYZ person who was born in 1960 and who died in 2010.
hmm
And then there's another ABC who was born in 1960 and died in young 1970.
hmm
And consider there's more data like that. DEF, GHI. Um, let's say that this is 2000, born in 2009 and died in 2014, 15, and then somebody was born in 2010 and then died in 2020.
hmm
This is the input data that you're given, and what you're expected to find out is the year in which most number of people were alive.
hmm I see. 1 second. So the name do not matter, right?
Yes, the name wouldn't matter, but you're free to actually store this as you want. If you don't want to store the name, that's all fine.
Okay. So let's. How many people are we having?
Um, well, you can actually consider that to be within the range of integer.
Okay, that it's going to be an array of integers. And diet it's always larger than or equal to born, right?
That's correct.
So let's say if they are equal, then does it count as being alive?
Yes, you will count that person was alive on in that year.
But let's say like in year two, like it's born and died at the same time, and we still count that as alive.
Yes, you still count that in the year two there was one person alive.
Okay.
Good question.
Um. Okay. So in this example, let's see. When we are at one, so let's say like if we sort this list by born and then died, we what we have is on 1960 and then 1970, then 1960, and then 2010, and then 2009, and 2015, and 2020. Okay, we need to find a year, right? Not like the number of people that are most alive in some year.
Yes, you just need to find the year in which most number of people were alive.
Mm. So, is it safe to assume that like it's within what's the maximum and like minimum number of years that we have,
You
or do
can
we
actually
assume like
consider within reasonable limit.
so like integers?
Yes, you can consider them as integers, and let's suppose, to make it simple, they are all between 1900 to 2020.
Okay. I mean, if that's the case, then we just need like one scan from the beginning, from the first year to the end, and find out. Um, like so, for example, if from from that, if we start at 1960, for example, in this example, and number of people increased by one, and another 1960, so now it's like two, and then 1970 we have one because uh, one person died, and in 19 like in 2000, actually 2009, we have two people. 2010, one people died, and we have another people born, so it's two. And also in 2020, 2015, we have one died, so it's one. 2020, one person has it zero. So in this case, do we return this number or this number or this number?
Uh, Good question. So if you have, and I mean 1960 also, I think it's the same as two. So if you have years which have equal number of people alive, you can return any of them.
Okay. I'm just noting down the constraint. And okay. Um, so I'm thinking of like a if we like for each year, let's say we count how many person like died or how many person was born that year. So each year we'll have like two properties basically,
Hmm.
and we can just scan through the years and like we scan through each year and keep track of the most. I keep track of the number of people alive currently, and then like get the max and return that.
Okay. So what do you think would be the complexity of that particular problem, space and time?
So so to process, like to basically to process, pre-process would take um let's say the input it's like n people, then
Mm-hmm.
processing would take o(n) time, o(n) space. Actually, would that be o(n) space? It would be like rough, actually o(2n) space, because uh each person, like assuming there's no duplication in terms of the years, and then each person will have like a born year and died year, and so it's o(2n) for space. And later on, when we scan through all the years, um, it's it's scanned through all the years. Probably take o(2n) as well. So in summary, it's gonna take o(n) space and o(n) time.
So can you actually walk me through your approach, and then we can actually confirm your complexity accordingly?
Yeah. So previously I mentioned like sorting, but I don't think it's needed.
Mm-hmm.
Mm. So for example, um, let's say we have like a hash map, and with all the years
Okay.
that we have, 1960, 1970, um,
Mm-hmm.
2010, 2009, 2010, 2015, 2020, right? And there are two attributes. So let's say the first one, it's we could be like more clear in terms of like B for born and lit, and D for died.
Okay.
Yeah, for each of them. And so we know that two persons were born in 1960 when we go through the list. So like here's like two, and no one died here, so zero. One person died. Sorry, one person died.
So basically, one quick question: you are only you are only considering the years that are given in the input for your keys in the hash map, right?
Uh, that might change later, but for now, I think only these would be necessary. But
Okay.
yeah, so because we assume that the years are between um, like these two numbers, so we can do
Mm-hmm.
a scan between these numbers and find out. But I don't think that's necessary. But I'll think more about that case later. Let me finish this example.
Oh, yeah. Go ahead.
Right, one person was born here, so like one, and then one died. No one died. And this year, so zero. Then one person born, one person died. Then 15, no one was born, and one person died. Zero was born, and one died. So if we go through the years in a clock, like in increasing time, currently we have two, and then it's two minus one, it's one, and then one plus one is one, and then 10. This is one plus one minus one is one. 1 minus 1 is 0. Oh, I think I did something wrong.
Um,
2 times
so
9.
this should be 2. So 1 plus 1, 2. And then that will be 2 plus 1 minus 1,
Oh,
so
yeah,
2 here. And then
right.
this. I get the idea,
Uh,
and it's good.
yeah,
So,
thank you.
yeah.
Yep.
Okay, so
Uh,
my question is actually even um, this looks actually a good approach. Like you are considering all the years that are given in the input, and then you are laying out at those particular years how many people were alive. Now, my question is, how do you create this kind of data?
how do I
Like you
create?
actually just, yeah, we just could scan through this and know that there were two people born in 1960 because we
Hmm.
can see it through our eyes, but some we have to do it algorithmically somehow
Right.
to
So
create this
there are
data.
two ways. Right, right. So there are two ways, right? First is oh, actually, uh, so can I write a code or do you,
Yeah, yeah, go ahead.
actually, let's not do that. So we can just go through the list, right? And then like, create a hash map and add the year in as we proceed.
Okay.
So, so something like, for one died in, let's say, the inputs, it's an input, for example, and then you have like a hash map,
Mm-hmm.
something like that, and yeah. So if you go through all the items in the inputs, you have this hash map, similar to what I have here.
So basically, you get the born and die from you get that particular year, born and die,
Yeah.
and then the hash map. Um, okay.
So
Yeah,
here
I
I'm
think.
assuming that at the inputs come as like array, even though like arrays of tuples like this.
Mhm.
Um, like, but in the beginning you were saying like you have some data structure like this, right? So can you like how many like the what is the desired input that you want?
Sorry, I did not get your question.
So at first you said you have something that looks like a dict like this,
Mhm.
but uh, when I process, I was assuming having an
Oh yeah,
array
don't
of
worry about the
tuples.
input. Yeah, yeah,
Yeah.
that's totally fine. You can have the
Hmm.
input as you want to have. It's very open-ended in that case. Um, and I could actually understand from your code here, like this is how you are building your. Basically, you are taking um, the input that you have is in this
Hmm.
format, right? So
Hmm.
you are getting born and die from these. So you're
Hmm.
basically considering this is the born year, die year, and you basically append the death or the born from these. So this actually sounds pretty reasonable to me. So now
Hmm.
actually we have something like this.
Hmm.
And what you want to do, and I guess this was the pre-processing part. Now what we want to
Hmm.
do is get this part.
Mhm.
So let's work on that.
Okay. But did you just type that?
No, I didn't. Sorry, it might have been. I don't know. I didn't type anything.
Oh, that's weird. Well, hmm. I don't know if someone like hacked into this thing. That's weird.
Sometimes speech is on, so that might be it. It's hearing you speak something and
Okay.
typing it out.
Um. So when we so so we need to go through the years in a sorted order, basically. And one way to do this is to have like a years array, and actually you have like a set. And when we add the years from the input, we can add the years into the set as well. So you set that add born, and with it will automatically like discard the duplicates, right? So then later on we can create like a array from that. So like and then we can go through the years in order. So for years, um, let's say the current that we have is 0, and the end of life is 0. So answer is like the year. Um,
Correct.
and, and if we go through um, the year in order, we go n a life is equal to n a life plus see how many was born in that year, and then increase by how many was died in that year. Actually, so here's one thing. Because for the case that we discussed, when the 2 years born and die are equal, we
Mm-hmm.
we still count as one, right? So
Correct.
right, so then we need to check the result immediately in that year before we do the subtraction. So if n alive it's larger than say max alive, then update max alive to be n alive and answer to be the current year. And then also we update n alive it's equal to n alive subtract by that year. But yeah, I don't think like when we subtract we would need to update the we would need to update the result when we subtract. We only need to do result date when we add. So when we out of the loop, we can just return ends.
Can we actually dive deep onto that thought about if the year is same for birth and death? Um, we want the count to increase. So I can see that you are actually doing that when you do on line 58, you do that.
Mhm.
Um, and we do not want the count to decrease, right? In that case.
Um. So actually, actually, right. I mean, yeah, you're right. Actually, we need to update it along the way.
Hmm.
So if n alive it's larger than max alive, you need this update. So that is mostly because these two are independent. Like the subtraction and addition, it's independent from the max alive. So we need to check it along the way anyhow.
Okay, I see what you're trying to do. So here, you're adding number one, and um, you see if you actually get the count increased, which I guess in most of the times you will actually have it increased. Um, and then you actually subtract the number of deaths and then try again.
Mhm.
But this might actually not be so useful because I'm hoping that this is always greater than whatever answer this is going to give us, right?
Mhm. Mhm.
The problem might actually occur when you actually go into the next iteration
Mhm.
and the count that you wanted to take, um, I mean, you will be fine because you probably want to actually consider the person dead in the last year and then go forward with computing your number of alive for the next particular iteration, if that makes sense.
Mhm.
So
Uh,
let's back a little bit. So yeah, go ahead, and you were saying something.
could you give me an example of the case that you are thinking of?
Yeah, let's actually build it up together. So let's suppose we have somebody dying and born and died on the same year.
Mhm.
And let's have something like that. 2001, 2002, and one more for this guy. Okay, let's first try to see what the answer should be for this. So
Oh
we
wait,
have
so this
in,
is, sorry, this one it's like this, right?
oh yeah, yeah,
Okay.
2000 to 2000. For year 1991, 1999, there was one person alive. For 2000, that person died sometime in 2000. So he
Mhm.
was alive in actually in 2000. Then
Mhm.
this guy was alive in 2000. This guy was alive in 2000. So answer three here. And in 2001, um, we have,
Wait. So that person died in 2000, right? But then this
yes,
person also died in 2000. Um,
correct.
this one was born in 2000. So we have two
Yes,
born. Um,
correct.
I see. And then like one carry on from that. Okay. So
So,
max is
I mean,
3. Got it.
yeah. And then 2001, we are just having two people in there. And then 2002, we have one.
2001 it's 2 because two person died from this one.
Yeah, so there's actually one person who died in 2001. So he was alive in 2001, and then one person was born in 2001.
No, so actually this person died, this person died. So 2 died, right? And then this person I see was born. Okay, so but next one it's yeah, you need to subtract. Okay.
So it is possible actually they never had an intersection. Like this person and this person maybe, they might not have an intersection. But
Mhm.
for the sake of simplicity and incompleteness of the input that we have, you can consider that they'll always have an intersection if the death year and the born year is the same of two
Mhm.
different people.
Mhm. Um, so what do you want me to do?
Okay, so let's actually try to build this together because you're doing very well. And the approach that you have taken is very close to a good solution.
Mhm.
But let's actually think. Okay, let's go back to that example that you have. So what you have done is actually lay out. Um, so let's use this example and build what you have here and see
Mhm.
if we can actually change our algorithm to map the requirements.
Mhm.
So this is how it would look like. I'm going to copy this over. Okay, so you want for 1999, let's first lay out all the years, right? That's what you wanted to do. 2000, 2000, sorry, 2001, 2002. So you lay out the years,
Mhm.
and
Okay.
then so now we start building up using this example. That will actually clarify the
Okay.
picture for you.
Sure.
So how would you build it? You can take it over from here.
Okay. Yeah. Let me take it over. So, um, right. So, um, there was only one person born in this, and then two-person was born in 2000, and like two-person died in 2000. 2001, we have one born, one died, and 2002, zero born and one died. Okay, um, so currently, like the current number of people alive is zero. Start right there, and born so like one, and then one plus two, and then we get max plus two is three, and then like we update, and it's now 2000, and then we subtract two from three. Two-person died,
Mm-hmm.
right? So then next, um, one person was born, so one plus one is two, and it's still 2000. And then one person died, so two minus one is one. Um, next one, no one was born, and one person died, and it's still 2000. And one minus one, it's zero. Hmm.
So for the year 2000, um, oh yeah, it's actually correct. Sorry, go ahead.
Yeah. So
So you built
the
up
answer
right,
is
right?
2000.
Answer is three because this is what we are looking for.
The answer is the year, right?
The answer is the year, sorry, 2000.
Yeah.
Okay, so this is looking good. Actually, your approach is good. And we can talk about optimization and complexity afterwards. Do you want to code this up?
Sure. Um. Okay. Can we? Oh wow. Okay. So let me do def year most alive, and the inputs are like people And then like when we call this, when people I don't know if we can do like assert 2000 for the test case that we are for this test case. All right, so we first need a hash map. So and we need to import from collections. And we go through the year. So
one quick question actually.
Mhm.
I mean, you were actually already touching on this, but you said that we need some kind of sorting. So do you want to think about where you want to implement that?
Oh yeah, so actually I don't think we need sorting. Um, we just need to keep track of the maximum and the minimum maximum, then we can go from minimum to maximum year. So previously, here is where the sorting happened, but now I don't think we need it.
Which line are you pointing to? Oh, 68. Okay. All right. I see it where you have done it last time. You sorted the years, um, and then for all the years you were actually implementing this. Actually, what I did not read this line last time you had written down, but I think you would require sorting. You were right in the first thought,
Hmm.
because otherwise, what else do you actually suggest? If you do not sort, what is your alternate solution?
Yeah, so if we do not sort, we just need to keep track of the min year and max year. So like uh, when we go through the years in total, let me just do it now as well.
Okay, okay,
Yeah,
sounds good.
min year, max year. So max year is like we can put 0, and then min year, um, max year, and then min year we can put like 2021, because we know that
Mhm.
yeah. All right, so for Bondi in people dot items, min year, min year, and born. So born it's always less than died, so we don't not need to like take the mean between born and died. And then same for max year. So max year died. Okay. And we also need to construct um born the one. One. All right. Um, and um, so then later on, we can just go from min year sorry, year in range in year to max year. We need to plus one because it's exclusive in Python.
Mm-hmm.
And the current alive it's 0 and ends it's 0. So as we go, for alive, go to year. See how many people was born that year, and then we check the max. If we need to max alive, is larger than max alive, and max alive is equal to cur alive, and it's going to be the year, right? And we do the same thing for alive year. I guess we probably could have like a function to do this update as well to avoid like copy and pasting code.
That's all right.
Yeah. And it's equal to year. And so finally we return ends. And right, so for that test case, it's good. I want to have another test case, so let's say this one. This should return. I think it's gonna return like the first one, like the first year with the most people, because it doesn't update when the numbers are equal. So I think 1960.
Yeah, that's real right.
Okay, so let's go through this code to see if there's any problem. Now, if the input is empty, then what do you want to return?
Well, you can actually throw an exception, or you can just consider for this example that input will never be empty.
Okay, sounds good. If there is one item in the input, okay, min year and max year. Okay, I think this will work.
Okay, so let's give it a try when you're ready.
This object has no attribute items. Yeah, why? Actually, yeah, there's tuple is not callable. This is weird. Perhaps you are missing a comma. Yes, I am missing some comma here. We can also print out. Right. Why does it print out 2010 in this case? So the first one is correct.
I mean, 2010 is also one of the correct answers.
Yeah, but it shouldn't be updating. I let me see. To double check, I'll print out the year and the number alive. So if um, per alive is larger than 0, then print. This is button 3. Okay. Um, per like year. Okay. So max alive is 3. Um, 2000, 2001. So like there was one point in 2001 before we. So in the second test case.
So in 2010, there was one point when there were 3 people alive, because this guy, and this guy, all 3 of them should have been alive in 2010.
Um, sorry, I guess you are talking about like the second case, right? I'm looking at the first case. I don't
Oh,
see
okay.
why. Yeah, I don't see why like 2001. Oh, never mind. Like current alive, it's correct. Max alive, it's also correct. Yeah, and 2010. So max current alive is.
So what's the confusion? Maybe I can help.
Um, so based on my, I don't see why it does like update the answer when the current alive it's less than max alive in 2010. Um,
So you're now talking about the second case, right?
yes.
So let's think about what other possible solutions can there be. Um, 1960 to 70 is out of question because we only have like 2 people in there,
Mhm.
and then 2009, we might have had only maybe one person. Then 2000, oh sorry, 2 people actually there also, and in 2010 this guy was born, so we got an additional person in there. So that's why the answer 3 only applies to 2010 year,
Okay, so
right?
somewhere. So
Yeah,
okay.
maybe we copied over the test case incorrectly, or when we were analyzing here, we might have done a
Mhm.
mistake. But you know, this is correct according to the requirements that we are considering the death year also, as person being alive in that year.
Mhm.
Um, we might have been talking here, in before we actually coded up. We might have considered something differently.
Mhm. Okay.
One thing that I
Yeah.
actually am not quite clear about is, and this is something that I was talking earlier too, like why do we have to make this check, this particular thing, 21 to 23 line?
Um. So okay. Let's say this didn't happen. Assuming that didn't happen. Um. Assuming that didn't happen. And Assuming that didn't happen. Sorry, assuming this one. If we add more
So,
people, then it might get it could be higher than max alive. Um,
mhm.
if we subtract, then it will be lower always. But um, could it could there be any case where we haven't reached that number? Um, haven't reached the max. Haven't reached the max. Correct. Mm,
That is not possible, right? If suppose
yeah,
your
that.
current alive, um, if your max alive is one anytime, then you'll probably actually reach it here itself.
Yeah, yeah. I think you're right. That would
Let's
not.
try removing it and see if it changes anything. So this condition, yeah.
2010 and 2000. I
Yep.
could.
All right, wonderful. I mean, we have few more minutes because we started late because I joined in late. Just want to see your thought on how would you model this if suppose the input had the year null for, or sorry, none for a person who hasn't died yet.
A person who hasn't died yet.
Yeah.
So then, like, if that is the case, then in the processing, if if uh die, it's not none. Then we do that. Otherwise, we do not need to do that. And so another thing is we need to go through like the current year, right? Like we
Uh,
don't like. Let's assume that we have like a mm, we need to have like some number that is larger than or equal to like the max in this
mhm.
case, and we can go through that. Like if we output a number like not inside the input, would that be okay?
Um, Sorry, I did not get the question.
Okay, so let's say the current year it's 2020. Can we output that number
Mhm.
if it's not in the input?
Yes, you can. In that case, it's possible that you can you will have that number, or you can actually also have the last largest number that is there, because I
Hmm.
guess they will be the same.
Yeah, so I can just like get the max number and then like increase one from there and see.
Yep. So, I mean, what you have right now is, I think, would also work that a person, if it's none, then we do not actually increase the counter of die
Hmm.
uh, for, and that would actually give us a good count. So let's try this one. Uh, let's do that. We actually get the year 2010 only marginally. Um, so we're two here and two here. 2011. So one more guy here. Okay, so the answer here should be 2000. Let's do one more. Okay, now we should definitely have 2011 as the answer because we take the first one and we do not update it.
Hmm.
So this one actually alive in 2011, this one alive, and this one alive. So let's try and see if you can install dry run if you want.
Mm, line 8. Oh, I see. So I was calling min max on that. So um, the null it's only for the diet case, right?
Yeah.
And okay, last year I think we also need to update the max because previously I was assuming that born is always larger than diet is always larger than or equal to born, but sometimes we don't have the year the diet year, so we need to update here as well.
Hmm.
Mm, born.
Okay. Awesome. Yeah, that's what the answer we are looking for. Okay, so let's talk about complexity again. So let's first talk about time complexity.
Let's talk about time complexity.
So let's talk about time complexity first.
Okay. Um. All right. So this will be proportional to the numbers of people that we have in input. Um.
Okay.
So yeah, this is on
Hmm.
on right here, and when we go through the years, it um it depends on the min year and max year that we have in the input. But let's assume that
Hmm.
um, the min years, it's like both of the year at the boundaries that we have before. So 1990s. Sorry. Uh, so the let's assume that the min years is always like 1900, and the max year it's like 2020. And
Hmm.
this is like independent of n. So this has constant runtime.
Hmm.
Um, so overall it's on.
Okay, and n is the number of people.
Yes.
Um, all right. So um, if we have, I mean, when you are actually describing this, you would say that the complexity is of n plus, let's suppose your range is k, right?
Hmm.
Um, okay, so open, you think this is constant, that's why it can be considered as depending on the number of people in the input.
Hmm.
Okay, that's reasonable. Let's talk about space complexity.
Space complexity. We need a hash map and for all the years, and so it's actually okay for the hash map, and each would have two attributes. So 2 times k is the time range. So you can say okay for space.
Okay, sounds good. All right, those are, I think, the right answers. Um, and this is where we can actually conclude our interview. But there's also one more point I want to make that you can actually optimize this a little bit more on the space because now you actually basically your complexity is O of k. You
Hmm.
can actually bring it down to O of 2 of n. Um, and it might seem like, O of k is not such a big number, but depending on how the input is, you don't have to actually um, calculate this particular value for all the years. You just have to calculate it for these years in question,
Yeah, but
if
what if
that
like
makes
we
sense.
have a million person?
Uh, I mean, you don't really know how the input are, so both of them are valid answer. I'm not going to say that this is the right approach and that is not. But usually, like we would not want to calculate for all the years, because those that data is not helpful to our calculation.
But in terms of like space complexity, we know that k it's constant and n could grow arbitrarily. So in average, k is I think it's better than n
Okay, I
on
actually
average.
accept your answer. That might be better in that case here. Okay, so that brings to the end of the interview. We'll do a very quick um, feedback
Hmm.
both ways, and we can wrap it off. So let me first actually start. I feel that you have asked the right questions, and then you actually, um, before even you started coding, you knew, things that could actually, things that really were not clear. So you were trying to iron them up before you started coding. I helped you in a couple of places, but I think you were almost there, so you didn't need my help. So that's a good thing. One suggestion I would give is that if you get stuck, just communicate. If at a particular point of time in the interview, I wasn't sure if you want me to help you, or um, you're thinking about something and you want to be silent. So just let the interviewer know what is in your mind.
Hmm.
And you're very good at communication, so I have no complaints on that part. This is actually a very tricky question because it's very easy to when you think about it. There are multiple ways to do it. You actually started off thinking on a very solid approach. There are other ways which are not so optimized. So that was a good start. And then you can actually also figure out how you do not sort, which is also additional benefit. I really appreciate that. Then the good thing is that you had the test ready, and there was a point where you probably were not able to understand why it's getting updated to a different value than you were expecting, and you had your minds there. So that's a good thing that interviewers can see. Um, I mean, all those feedback I think are very standard. Uh, I like that you actually write your assumptions. There were few assumptions that were not actually written down or asked. Like, when I had brought into this, into the question that, sometimes a person cannot even die, and then you should probably model it by yourself without interviewer telling.
Hmm.
So those kind of cases are also good to handle.
Hmm.
Um, Yeah, I think you did really well. You have good command over language. Uh, you you once you have think thought about something, you can actually type it out fast, which is really helpful in the interview, which are timed. So that's all my feedback. If you have any feedback I can do to actually improve interviewing, I'll welcome them as well.
Um, I think overall, like you were very clear in terms of communications and guiding me through the whole interview process. The example was clear as well, and you were very like detailed in terms of like some parts. Like I was kind of confused, but then like you were pressing on that part and asking why I write such a piece of code, etc. So I think that's a good point. And you had like different follow ups and asked for space and time complexity and how to optimize. So I think that was helpful. And I didn't feel like pressures when I talked to you as well.
Okay,
But
good
yeah,
to hear that.
overall, like mhm.
I felt during the
Overall,
interview
I
that
feel
actually I might be. Go ahead, go ahead.
sorry. So yeah, so at I think overall it's good. There was some silence that I don't know like what you wanted. So that just
Hmm.
but that just like a few 1 or 2 minutes or something. So,
Okay, got it.
hmm
Okay, so you're doing really well. I wish you best of luck for your future interviews, and just be confident as you are. You're doing very well.
Okay, thanks a lot. So are you like can we ask can I ask some questions follow up?
Oh yeah, go ahead.
Yeah. So are you doing mock interviews for people frequently, or because it's a part of your job, or why are you doing this?
Uh, it's not part of my job. I actually work in Seattle in a company. I have
Mhm.
um, this is more like me just being in touch with programming because I don't really interview with companies anymore.
Mhm.
So I mean, it's more voluntary.
I see. So how many years of experience do you have?
I have in total, I think 4.5 years of programming experience and then a couple of years of quality assurance experience.
Sorry, a couple of years of
QA testing?
testing.
Yes.
Oh, okay. I see. I see. So are you like a senior now?
No, I'm actually still software engineer level 2. So it's like L5.
Oh, okay. I see. I see. Um, yeah. So I'm targeting for L4. I don't know if you have any suggestions
I
going
think you're
forward.
doing very well. You're doing very well. I think no matter what happens in the interview, don't give up because
Mhm.
sometimes you get the answer in the last 5 minutes and that turns around the interview completely. So just keep trying. Listen to your interviewer. They are always giving you hints. And I mean, no matter how you think interviewers are judging you, they really want you to succeed because it makes their life easy if you succeed. So just remember
Mhm.
that in your mind. Don't become conscious or things like that. Don't stress out. I know these interviews are really stressful. Like everybody goes through them, but just stay faithful to yourself and trust yourself, and you should be fine.
Awesome. Yeah, I appreciate that. Thanks a lot.
Okay. Thank you so much for interviewing with me today, and you have a good day or night.
Thanks a lot for taking the time. I'm in Seattle as well.
Okay.
Yeah.
And
Have a good night.
I'm gonna share my contact, so if you want to share yours, we can do that after this interview. I think
Sure.
this tool gives you an option to do that.
Oh, in the platform we can do that?
Yes, they once when you actually when we exit this, there will be a feedback form, and you can actually
Mhm.
mention there if you share your contact or not. So we'll share our email addresses.
Oh, okay, okay, got it. This is my first time, so I didn't know that. Thanks for letting me know.
Yeah, sure. All right. Good night.
Sure. Good night. Bye bye.
Bye.